Okay, so now we want to find all the points, if any, where the graph of the function has a horizontal tangent line. So the first one that we're going to look at is f of x equals x cubed plus x squared minus x. So first step we need to do is find f prime of x. Find the derivative. So f prime of x in this case, using the sum and difference rules and the power rule, is 3x squared plus 2x minus 1. All right, so our next step, we want to set this, so we want the values where it has a horizontal tangent line. So remember, if we're asked to find where it has a horizontal tangent line, this is the same thing as saying find the values where f prime of x is equal to 0. So we want to set this derivative, 3x squared plus 2x minus 1 equal to 0. And we want to solve that. So if we look at this factors fairly easily. And remember, I would always go factoring, and then if factoring doesn't work, try something else like completing the square or using the quadratic formula. But I usually try to save those as a last resort. If something's going to factor, chances are you're usually going to be able to factor it much quicker than you're going to be able to find it using the quadratic formula. So in this case, this one factors pretty easily. So 3x squared plus 2x minus 1 factors as 3x minus 1 times x plus 1. And set that equal to 0. And so now remember, zero factor property tells us, okay, we can set each of these equal to 0 individually. So 3x minus 1 equals 0. X plus 1 equals 0. So 3x equals 1. X equals 1/3. And then x equals negative 1. So we have two different x values where the graph has a horizontal tangent line. So x equaling 1/3, x equaling negative 1. But we're not done. I asked you to find the points. So if we want the points, well, that means we need an x and a y. So a point in the plane, so a point in our regular x-y coordinate system, has to have two pieces, an x and a y, to get its address. Think of it like when you're mailing a letter, if anyone still does regular snail mail anymore, you have to have the street with the house number and the zip code for your letter to get to the right place. So here, to get to the right place, you got to have the x and the y. So you got to have the full point because I asked for the full point. If I just said find the x values, then you could just tell me, okay, x equals 1/3, x equals negative 1. But I asked for the full point. So let's find our y coordinates. Now remember, to find these y coordinates, they're the y values of the original function of f of x. So we've got to find f of 1/3 and f of negative 1. So f of 1/3, that's positive 1/3 cubed plus 1/3 squared minus 1/3, so 1/27 plus 1/9 minus 1/3. Getting a common denominator and simplifying this, so that ends up giving you negative 5/27. And then similarly for f of negative 1, that's negative 1 cubed plus negative 1 squared minus negative 1. So that gives you negative 1 plus another 1. And then you end up with a positive 1 for that. So the points where this graph has a horizontal tangent line are 1/3 negative 5/27 and negative 1, 1. So let's look at a second example. So g of x equals 1 over x to the 4th. Well, remember, to differentiate this, we want to first rewrite it so we can use the power rule. Use our exponent rules. In this case, the negative exponent rule. So 1 over x to the 4th becomes x to the negative 4th power for g of x. So then g prime of x, so now we're finding the derivative, so we use the prime notation. Then using our power rule, so bring the negative 4 down, becomes negative 4x to the negative 4 minus 1, so negative 5. So negative 4x to the negative 5th power. And rewriting that, so we have g prime of x equals negative 4 over x to the positive 5th power. So we have our derivative. Now we need to set that derivative equal to 0. So negative 4 over x to the 5th equals 0. So negative 4 equals 0, so multiply both sides by x to the 5th. And that's not true, right? So because this is not true, we can't get a solution, so there are no points with a horizontal tangent line. Later on, we'll look at this and we'll mess around with it a little bit more. But for now, there are no points with a horizontal tangent line. For our third one, so f of x equals x minus 2 cosine x. And in this case, I'm going to restrict it because we know cosine x is defined everywhere and repeats. It's a repeating function. So then we know in this case, if I didn't restrict where we're looking at, you'd have infinitely many values. So I'm going to restrict it to negative pi pi. So I'm just going to restrict it to that open interval. Let's find the points where this graph has a horizontal tangent line. So same idea. So find our derivative. So f prime of x is going to be 1 minus 2 derivative of cosine is negative sine x. And so then this becomes 1 plus 2 sine x is our derivative. So f prime of x is 1 plus 2 sine x. Now we set that equal to 0. So 1 plus 2 sine x equals 0. So then that means 2 sine x equals negative 1. Sine x equals negative 1/2. So then x now on the interval from negative pi to pi, the values where sine x is equal to negative 1/2 end up being at negative pi over 6 and negative 5 pi over 6. So we have our two x values. Now we have to find the function values of those. So f of negative pi over 6. And I want the exact value, so you can't just plug this in your calculator. You got to give me the exact value of these. If you just give me a decimal, you're going to get some points off. So f of negative pi over 6, so that's negative pi over 6 minus 2 cosine of negative pi over 6. And so that gives us negative pi over 6 minus 2 times square root of 3 over 2. Or negative pi over 6 minus root 3. So the 2's cancel, which then, getting a common denominator, we end up with that y value, or in this case, f value, the value of the function, negative pi minus 6 root 3 over 6. Similarly, doing the same idea for f of negative 5 pi over 6. So that's negative 5 pi over 6 minus 2 cosine negative 5 pi over 6. So that's negative 5 pi over 6 minus 2 times negative root 3 over 2. And so that's negative 5 pi over 6 plus root 3. And then that gives us negative 5 pi plus 6 root 3 over 6. So then our 2 points in this case are negative pi over 6 comma negative pi minus 6 root 3 over 6 and negative 5 pi over 6 comma negative 5 pi plus 6 root 3 over 6.